Hello everyone, once again this is Sir O, your teacher. So if you're new to my classroom, I will really appreciate if you can subscribe to my channel and please click that notification bell for you to be updated, notified with my next session. So today, yes, you will learn how to transform, convert, or change standard form into vertex form of quadratic functions. Now, the standard form of quadratic function is written as f of x, which is also equal to y, is equal to ax squared plus bx plus c. So therefore, this is still a degree of 2 function. So the vertex form is also written as f of x is equal to a open quantity x minus h closed quantity raised to the power of 2 plus k, where the vertex is at h and k. So if you are now ready, let us now go jump to our example. Example number 1 is actually written in the standard form of quadratic function. So our task on this is that we will try to transform or change or convert this standard form into vertex form, and we will also identify the vertex of the given function. So the very first thing that you're going to do is we will group those terms with variable. So that is y is equal to, by the way, before I proceed, I change f of x by y because they are just the same. So if you notice, we group already the term with variables. So after this is that we will try to complete the trinomial into a perfect square. But the question is, how do we complete this trinomial into a perfect square? So what you're going to do is we just get the coefficient of the linear term, which is 4 divided by 2 always, and raised to the power of 2. 4 divided 2 is of course 2 raised to the power of 2 is equal to 4. So that is why we added the given terms here by 4 so that this will become a perfect square trinomial. Now, since we added 4, we will also subtract this by 4. Why? Because we did not change the equation. So if you notice, 4 minus 4 is just 0. So multiply this by 1. Why 1? Because the coefficient outside this quantity is actually 1, which is imaginary. So I multiplied it by 1. Minus, then I just copied. So after this, you are going to factor this out. Okay, since this is a perfect square trinomial, so we have x minus 2 squared. How did we obtain that one? Square root of x squared is x, and the sign of the middle term is negative, so therefore it's also negative. And the square root of 4 is 2. So negative 4 times 1 is negative 4, minus 10 is of course negative 14. So this is now the vertex form of the quadratic function. So since we are asked to find the vertex, which is at h and k, our h and k is this one, 2, and our k is negative 14. So therefore, our vertex is at 2. Why not negative 2? Because we will get the opposite. So since this is negative 2, so that should be positive 2. And the value for k is negative 14. So if you have some questions, you can always write your question in the comment section. I will be happy to answer them. Example number 2. So this time, this is also written in the standard form of quadratic function, and we are asked to find its vertex form as well as the vertex. So what we are going to do is, of course, our first step is we will group the terms with variable. So that is negative 2x squared minus 12x copy plus 6. Now, after this, we will factor out the common, which is negative 2. So, we have negative 2. Negative 2x squared divided by negative 2 is x squared. And negative 12 divided by negative 2 is 6 copy x plus 6. Or, if you're going to distribute negative 2 to each term inside the parentheses, we will arrive with the same expression, which is negative 2x squared minus 12x. So after this, we will now complete the trinomial so that we can make this as a perfect square. So negative 2 we just copied, then x squared plus 6x. So we are now after with the third term so that this will become a perfect square trinomial. And of course, we will just get the coefficient of the linear term, which is 6 divided by 2 squared. 6 divided 2 is 3 raised to the power of 2 is of course 9. So we added 9 so that the trinomial becomes a perfect square trinomial. So we added 9, so we will also subtract 9. Now since the coefficient outside the parentheses is negative 2, so we will also multiply negative 9 by negative 2. Copy plus 6. So since this is now a perfect square trinomial, we can factor this out as negative 2, we just copied, x plus 3, because the square root of x squared is x, and the sign of the linear term is positive, and the square root of 9 is 3 raised to the power of 2. Negative 9 times negative 2 is positive 18, copy positive 6. Simplifying further, we have f of x or y, you can use y if you like, is equal to negative 2x plus 3 squared, and 18 plus 6 is positive 24. So we are now ready to identify our vertex because this is already in the vertex form. Of course, this is our h and this is our k. So therefore, the vertex is negative 3 because we will get once again the opposite of positive 3, that is negative 3, and k is positive 24. Example number 3. F of x is equal to negative 5x squared plus 6x minus 5. So once again, we will transform this one into vertex form and we will identify the vertex. So once again, we are going to group the terms with variables. So we have negative 5x squared plus 6x, we group them as 1, copy negative 5. So this time, we will now remove or we will now factor negative 5. So we have negative 5. Negative 5x squared divided negative 5 is x squared. Now, if you notice, guys, 5 is not common here. So if you are going to distribute negative 5 here, so we can cancel the negative and we will arrive with 6x minus 5. Then after this, of course, we will now complete the trinomial so that it would be a perfect square. No? So y plus 9 over 25. So there is actually a proof. Okay, so what we are going to do, I'll explain this step by step so that you will understand why y 9 over 25. So what you're going to do is we will get the coefficient of the linear term, which is 6 over 5 divided by 2 squared. And of course, we cannot divide 6 over 5 by 2, so we just get the reciprocal of the denominator, which is 1/2, and change the operation to multiplication. So 6 over 5 times 1/2 raised to the power of 2. 6 times 1 is 6, and 5 times 2 is 10. So 6 over 10 raised to the power of 2. But since 6 over 10 can be reduced into lowest term because these are actually divisible by 2, so that would give us 3 over 5 squared. Distributing the exponent, so we have 9 over 25. So we added 9 over 25 so that it would be a perfect square trinomial. So we will also subtract negative 9 over 25, multiplied it by negative 5 because that is the coefficient outside our parentheses. So negative 5. Copy also negative 5, which is this one. Okay, simplifying this further and factoring this perfect square trinomial. So we have negative 5. The square root of x squared is x. The square root of 9 is 3. The square root of 25 is 5. Why minus? Because the sign in the linear term is also minus. So since 25 and negative 5 is divisible by 5, so we have 25 divided 5 is 5, and negative 5 divided 5 is negative 1. And negative 9 times negative 1 is of course positive 9 over 5 minus 5. So we will now combine 9 over 5 and negative 5, of course. That is 9 minus 25 all over 5 because the LCD is 5. So 5 divided 5 is 1 times 9 is 9. And 5 divided by 1 is 5 times negative 5 is negative 25. Simplifying this further, of course, that is 9 minus 25 is negative 16 all over 5. So this is now the vertex form of the given standard form of the quadratic function. So we now identify the vertex because this is our h, this is our k. So we will just get the opposite, so that is 3 over 5 and negative 16 all over 5. Example number 4. So this time, the given is already in the vertex form. So what we are going to do is we will transform this one into standard form. So what you're going to do is we will apply our knowledge in the square of binomial. So if you notice, if the given quantity is addition a plus b raised to the power of 2, that is equal to a squared plus 2ab plus b squared. But if it is also minus or subtraction, that is a squared minus 2ab plus b squared. Now, by the given quadratic function in the vertex form, if you notice this is plus, so we will apply the first formula for square of binomial because we will expand this one. So this is the expanded form. So we will expand this as x squared plus 8x plus 16 plus 5. Of course, simplifying this further, that is x squared plus 8x plus 16 plus 5 is 21. So this is now the standard form of the quadratic function. Example number 5. So f of x is equal to 3 times x minus 2, open and close quantity raised to the power of 2 plus 4. So we will now expand this, of course, using our square of binomial. So we will use the second one because this is subtraction. So expanding that one, we have 3 times x squared minus 4x plus 4, copy plus 4. So distributing now 3 to each term inside the parentheses. So we will distribute 3 times x squared. Of course, that will give us 3x squared. Next is we will multiply 3 and negative 4x. That is negative 12x. Next is we will multiply 3 and positive 4. That would give us 12 plus 4. So combining similar term, which is 12 and 4, we have 3x squared minus 12x plus 16. So this is now the standard form of the given vertex form of the quadratic function. So I hope you can give a like to this video and please do share this for others. And please do not forget to subscribe to my channel and please click that notification bell for you to be updated or notified with my next session. Thank you so much.